acceleration. What other force applied simultaneously will allow it to maintain constant velocity? Now remember, if an object has to maintain constant velocity, the net force on it has to be 0. Alright, what are the forces acting on this particle? Can you draw these forces in the XY coordinate system? What is the first force? F1 is 5 Newton at an angle 30 degrees to the positive x-axis, that is in the first quadrant. Here, F1 is 5 Newton at an angle 30 degrees in the first quadrant. The second force is 3 Newton 37 degrees to the x-axis in the third quadrant. That means it is this angle that is 37. Therefore, what is the angle that this makes with the positive x-axis? Remember, all vectors need to be identified with its angle measured from the positive x-axis. If this vector makes an angle of 37 degrees with the x-axis in the third quadrant, that is this angle, then the angle it makes with the positive x-axis is 37 plus 180, that is 217 degrees. So the two forces on this particle are 5 Newton at an angle 30 degrees and 3 Newton at an angle 217 degrees. We need to find the net force. That means we need to add these two force vectors. What do you do to add them? To add them, first we write the vectors in the component form. That's the only way to add them. So, how do we write this in the component form? 5 Newton at an angle 30 degrees. When you write that in the component form, it will become F1 is 5 cos 30 degrees I plus 5 sine 30 degrees J. The x component and the y component, and obtain their values. Now you got to do this along with me. Keep your calculator ready and obtain these values. 5 cos 30 degrees is 4.33 Newton and 5 sine 30 degrees is 2.5 Newton. Therefore F1 is 4.33 Newton I and 4.33 Newton I plus 2.5 Newton J. Now, the angle F2 makes with the positive x-axis is 217 degrees. Therefore, F2 is 3 cos 217 degrees I plus 3 sine 217 degrees J. And use your calculator to obtain these values. That will be negative 2.4 Newton I minus 1.81 Newton J. You have now identified the x and y components of both the forces. Can you add these forces now? Yes. The net force F net is F1 plus F2. So in adding, we add the x components and then the y components. You are familiar with it, is that right? So adding the x component, you get 4.33 Newton minus 2.4 Newton I plus adding the y components 2.5 Newton minus 1.81 Newton J. And this is the net force. Simplify these quantities. That will be 1.93 Newton I plus 0.7 Newton J. This is the net force on the particle. This net force is now going to produce an acceleration. Alright, we have F net equal to 1.93 Newton I plus 0.7 Newton J. Now you know that F net equal to ma, therefore A, the acceleration, is F net divided by m. Now notice here, F net has an x component and a y component. If you divide the x component by m, you get the x component of the acceleration. You divide the y component by m, you obtain the y component of the acceleration. So this will be 1.93 divided by 2.5 times 10 to the 6 F over m, the x force divided by the mass, and that will be the x component of the acceleration. The y force divided by the mass. Did I say this is the acceleration? No, this is the mass. The x component divided by the mass gives you the x component of the acceleration. The y force divided by the mass gives the y component of the acceleration. Simplify this, what do you get? That will be 7.7 times 10 to the 5 meter per second squared I plus 2.8 times 10 to the 5 meter per second squared J. This is the acceleration of the object in the component form. Can you write that in the magnitude angle form? Well, how does it look if you want to write it in the magnitude angle form? The magnitude of the acceleration is, how do you obtain the magnitude? This is the x component, this is the y component. The magnitude will be square root of x squared plus y squared. So the magnitude is A equal to square root of, well, square root of x squared plus y squared. So you need to square those quantities. It will be like this, 7.7 times 10 to the 5 squared plus 2.8 times 10 to the 5 squared. Alright, can you calculate that on your calculator? I'm going to leave it for you to calculate. Well, I have got a value here, and that is 8.19 times 10 to the 5 meter per second squared. That is the magnitude of the acceleration. Please check if I got that right. Or make sure that you square each quantity before adding and then take the square root. Okay, what is the angle or the direction of this acceleration? If this is the x component and this is the y component, the angle theta will be given by tan inverse of y over x. Is that right? Yes. So theta equal to tan inverse of y over x. And when you divide y by x, you notice that the 10 to the power 5 will cancel. It will simply be tan inverse of 2.8 divided by 7.7. And that is 20 degrees. The acceleration produced by those two forces on a particle of mass 2.5 times 10 to the negative 6 kilogram is 8.19 times 10 to the 5 meter per second squared at an angle 20 degrees with the x-axis. You notice here that we are using everything that we did in Unit 1 for adding vectors. Now here we are dealing with force vectors. Okay. Now, the second part of the question is, what force applied simultaneously on this particle will keep that particle moving with a constant velocity? Now, what is the net force on the particle that we just calculated? We just calculated that the net force is 1.93 Newton I plus 0.7 Newton J. This is the net force producing an acceleration on the object. Now we need to find what force applied on this particle now will balance. In other words, you have to now balance all the forces, that there will be no net force on the object, that the object will continue moving with a constant velocity. There will be no acceleration. Now what will be that force? In order to bring this to zero, in other words, you need to bring the net force to zero. Is that right? The only way to keep the object moving with a constant velocity is to keep the net force zero. Now how would you make this net force zero? Well, it's very simple. If there is a 1.93 Newton I, then apply a negative 1.93 Newton I will nullify the X force. If there is a 0.7 Newton J, then apply a negative 0.7 Newton J. That will balance the Y force. So the equal and opposite force will be F equal to negative 1.93 Newton I minus 0.7 Newton J. This force will balance this so that the net force will be zero. Okay, let's solve another problem.